This is a Gunnar 1001 computerized mat cutter, built in about 1998-2000 time frame. The computer is in this tower. I have it sitting on a pallet with an extra shelf that I built and another computer. This computer here has a PCI card in it. The original computers ran off an ISA card. These are running on Windows XP. So this is the tower. The part of the tower is down in this lower bin is the drives for the X, Y, and Z motors and a power supply. So the X and the Y are back there in the silver box. The Z is right here in the yellow and black box. And then that's a low voltage 24 volt power supply. The motors on the machine are connected through this big cable. Some Gunnars don't have this big connector. They have 3 separate cables going through grommets. Below that, you can see an opening right there. That's for this parallel cable that I have currently outside the machine. I have completely rewired this machine, and rather than using a solder type 25 pin D-sub, I used a screw type. The problem is that, you know, all the jackets of all the cables can't fit in that connector. The individual conductors can, but not the jackets of the cables. Now those cables run up and are attached to the bottom of the machine, and then they run out throughout the cable track along the back here and up on top of the arm, some of them along this cable track, and loops around into the cutting head. Some of the cables and wiring run underneath this side cover. I've got the side cover tilted out. It should be here covering the drive shaft, but I've tilted it over to work on it. These are the 3 valves. This K valve is for the cutting head. The M valve is for the blade, and the A valve is for the clamps. I have color coded all the circuits with different color wire or tubing so that it's easy to follow from a diagnostics standpoint. Originally it was not like that. Also, in the front of the machine here, normally this would be sitting back like this, but I have it tilted open. There's a regulator for each function: head, blade, clamp, a gauge for each regulator, a start button and a stop button, and it acts as an emergency stop too. And this knob down here is for changing the clamping configuration, which I'll explain later. It's called COE mode. So behind here is where all the connections are, and you can see each colored circuit going to a regulator, cutting head, blade, and clamps. There's also connectors for the wiring for the buttons. And then this mess of tubing down here is the back side of the COE button. All those cables or hoses go through the aluminum frame. And down here to the cutting circuits, to the clamp circuits. Okay. So there are 2 side clamps, 4 clamps along the bottom, and 2 right side clamps. The COE mode will make it so these 4 clamps, these on the right half of the table will work independently or opposite of the left bay. So while this is clamped, this is unclamped, so you can load work in it. When you clamp this, then this will unclamp, so you can unload this while the machine is cutting over here. COE stands for cut on ends, cut on each end of the table. In this machine, this cylinder, which raises the cutting head up and down off the table, and this air cylinder, which pushes the blade in. They were originally made by an Italian company, no longer made anymore. So I made an adapter kit to switch them to standard SMC cylinders. The adapter kit includes this plate here for new mounting pattern, and this guy right here, this block for mounting this cylinder. It's also thicker than the normal one. This is a quick exhaust for running the cutting head. There is a valve back in here. It's called the throttle valve. It is used to slow the entry of the blade when cutting ovals. This sensor right here, the threaded sensor, this is the home sensor. It detects this metal plate as the cutting head moves around. Once that metal plate goes at least halfway under the sensor will signal the computer that the machine is home. It's used during homing only. This is a flow control valve for controlling the speed of the cutting head. I've also, in rewiring this machine, I've removed all of the Molex connectors, which require special tooling, and replaced them with Phoenix connectors. So they're just screw terminal connectors. Some of the, now on the back corner of the machine here, this is the X limit switch. It used to have a cable, 5-meter cable that went all the way to the computer tower. Well, you can't buy these as an OEM. You can buy them in the lot size and they'll make them for you special, but off the shelf the standard is 1 meter. So when I rewired the machine, I put a new cable with a connector in this location here. This is the Y-axis, home and limit switch. During initialization, it's a home switch. During cutting, it's a limit switch. This sensor here is the X-axis home/limit switch. During initialization, it's a home switch. During cutting, it's a limit switch. This is a physical stop. This is the limit switch for the Y-axis. Again, those wires run through this aluminum tube, and they used to run all the way through all the cable track into the computer tower, and I replaced them. I put new wiring up to this connector, which allows me to connect these two switches in the arm at this location, which allows me to buy standard off-the-shelf replacement switches with only a 1 meter lead. This is the Y motor. It runs this pulley, which runs this belt, which pulls the cutting head forwards and backwards. This is the X motor. It is connected to this pulley, which is connected to this drive shaft, which connects that belt down there to this belt here, and that moves when the arm moves forwards and backwards. It's actually pinned onto the motor shaft and pinned here. And this is the back end connections. So this motor is the same as the Y motor. There's a cover that goes over this drive shaft on this end. I've got it laying right here. So right now I've got it partially apart so I can make this video. The table, the whole table, is tiltable. You can tilt it up or down on this cable system right here. There's a stop and another stop, but if you loosen this clamp on this side of the table and on the far side of the table, you can reorient the table and tilt it up or down, so it's easier to work on for you if you need to. Flat is the best, and most Gunnars are used in a flat orientation. Here's the clamp on the far side of the machine right here. So loosen this clamp underneath and loosen the one on the other side and tilt the table. This is the main air feed line into this distribution block, which feeds each colored circuit.